Hello everybody, welcome to the second lesson. Today we will modelize a sample beam in structure metallic. It's like RDMCs. If you use RDMCs, we will modelize a structure beam, steel beam with two support, sample support and uniform loads, and then for example node loads. So let's start. So the first stage I do here is define the preference. So here language and regional setting, it is error code for me, for you I don't know. So English, okay, accept. Here there isn't a lot of options to modify. You can, if you have a specific parameter, you can save it here in new name, not standard. For example, your name, your short name, for example, or the name of company you work with. So accept. The second things I can do, it's job preference here. So here I have units and format. So dimension, for example, I have meters, so it's good millimeters for structure metallic, for steel structure. So here for forces, for example, it's decanewton. So decanewton here. Moment on decanewton to decanewton millimeter. Okay, stress meganewton. Okay. OC displacement on millimeter to in other country it's not American dimension. So weight kilonewton or decanewton, mass kilo. Okay. Length units, here I can put millimeter. Forces decanewton here, for example. Okay, not a problem. Material, ici error code, steel, for example, I can use this. It's depend the steel type, steel nuance you have. So here, for example, material. Okay, so error code. So here you can change. Okay, you can verify. It depends the company. Here code combinations. No, it depends which code you work avec. For example, structure analyze. So here what we need is learn how to work with Robo. All these parameters depend the country where you are or the company you work avec. So okay, second things I can do, it's access from here. So access here, so it's a sample beam, so 0, so x here from this, so 0 0, and on millimeter as we see here. So we can put, for example, 4,000, for example, and I need an access for nodal load, so I mean a point, or for example we will not do that. So here I choose ABC 0 for example, and here I don't need meter, but okay, not a problem. So Cartesian here, apply, okay, close. Second step is material. Here say section and material here. So material, this material, not a problem. Okay, so then here, so I define previously I defined EBE 100, IBE 160. So here I can the same things. I will not. So I choose this. It's okay. Then define bumper. For example, this I just want to click here and click here. Okay, it's good. The number is good. So close. So then support is I choose peanut. So here and here. Okay, that's good. So for this moment I have this structure. Come, you see the support is disappeared. So we can play with here. For example, here node numbers, as you see 1 2, then member bar 1, so 1 I can separate. Banner description, support, this support section from here, local system, this local system, and here 3D system. Here we have loads numbers, we don't put load. So loads is the second, it's the next step. So I have to define dead load. So self weight I put, for example, like that, and then life load, so add, close. Then I have to start the calculation. For the program need to define the date load. If I don't start the calculation, I will not see the date load. So calculate from here. Okay, the things is good, or things are right. I can, for example, see table, and then I can see loads. Okay, so loads all table is in the bottom of the window. So we have here few, okay, and then load here. So this is a table of loads. So all loads I will see it here. So one date load, one self weight. So I have it's by minus z factor. If I have assemblies, if I have assemblies with the structure bumper, so I can put, for example, 1.2, for example, where I can put 1.2 if you want, and here I can, okay, and here I can write a nota, a remark for the note, for example, with a sampling. When I verify my loads, I will find this load. So few, then few, I go to where I go to load type. Okay, it's done. Then here, so I need the first stage. We will calculate another force, so I will put another force in the middle of this bar, but unfortunately I cannot put the forces if I don't have node, so I have to define node in my member structure number. I can put forces here or here. So for define a node here, I have to go to edit. I have to select the member and then go to edit, then divide. So here there is many options, so I can, for example, distance here, so I can from 2000 generate node without member ledge division. It will not divide our member by 2, so generate. Okay, I have a node here, it's good. So now I have a node here, I can put my force. So force here, so my force is which axis? It's Z, so I can put here, for example, Newton. I can put, for example 20, add. So then I have to define, I have to click the node, then apply. So I have a force here, close. The force is disappear. So for appear the load, I have to click here, and to appear the value of forces, I have to click here. So I have Van Newton here. So if I go to loads here, I have my force here, nodal force 3, so it's minus 20. It's okay. It's recommended to close this table, because I can modify it by mistake. So I can do mistake and modify the number here, and then it is a catastrophe for me. So to close this table, so table here, I have check here, so like that I closed my table. For moment it's okay. I have member avec two support and load. I have to define automatic combination. So for here I have to choose which code I work. So I have many codes here, and then I can verify the coefficient here. So day load I have 1.35 and life load I have 1.5. So it's perfect. So snow, etc., snow, wind, I don't need that. So manual combination I have 12. Simplify I have 4. So we can check simplify combination, and then more. So for more, here we have ultimate limit state, service limit state. We have the other combination I don't need, and here I don't need all of that. Quasi permanent I don't need. Frequent without coefficient I don't need. I need structure and ultimate and service. Just generate. Okay, here I forget to tell you I forget to tell you something. So here I have the force, the loads avec the combination. For example, if I need to define a load, I need to define which force here. So I can, for example, life load, we add these forces here. We add these forces here. I can add to a dead load here. I have to define dead load here, and then load definition node, for example, I can define, for example, 5, add. So I click here, then I click here, apply. So I have a load here. If I go to the load table, so table here and then load. Okay, so as we can see, I have 2 dead load, I have 3 dead load. I can modify from here too. So for 20 I can life load, it's good. Dead load, okay. So I can modify here, I can self weight. So for the second dead load, I add here, I can put a remark, for example, that we can do pipe, for example. So it's a pipe, for example. So it's okay. So we can play with this table. So table, I close. Okay. Then calculate. So here we calculate our structure. So here we have many cases, many loads. Then I go to result. Then a diagram for number. From here I got the result. From here or from layout model, from here I can go, for example, I can go to result. So result. So I have these windows. Start, for example. Okay. For example, loads. So I have these windows in front of me. Start, for example, I have this window. So what I need here, say my moment, so numerize like that. So I have a moment like that. If you calculate it, you will get it normally. Okay, I have this moment here. I can for diagram I can make it bigger or make it smaller way. Okay, for that I can get reaction too. So reaction here is see non-numerized, then reaction here, and then FZ numerized. So I have 2 reaction. I don't have value. So for value description here normalize. So I have here 24 and here 19. It's good. I can cut deformation. So deformation from here I can deformation numerize. So I have deformation in 0.2 millimeters. Okay, it's not a lot of deformation. Okay, so I have parameter, I have table, for example. So I can do with this parameter. So I build my project here, sample project. There is something to this my member here. What happened? My number, this number, for example, start. So the action. Okay, I can go to this, click to this member, and the click is see member. I have the properties of member. As we can see here, we have member 1 we have node, there is node it's not here, node 3, so I have 3 nodes. Each node have a coordination. I can modify it from here. It's okay. I click this beam. I have different properties. So here I have, for example, length. I have to which node to which node. So the type of section here, steers, and I have release. So release, it's for how we define the member, fixed or pinned. Is the buntless support? Is the bunt is if it can support the moment, or just force axial, just compression, tension. So we can define here. So if we put pinned, so this member is work with, there isn't a moment here, just force, compression, and tension, compression. So that is the last thing, how we have the result. So result from here. So from here, for example, we have this result. For example, we have all information about the member, the length, the properties of member we put in this project, and the support, and all the information we need. So here I just go here, and then I do print. I can see it from here, for example. So this is my result. So we can find plus complicated to this. For example, it's by default. So title page, project structure. I have all information here. So for a project, I can change the name. I can change the name from here, project properties. So file project properties, here I can put all information, name, address, city, data, all that will be appear in the top of this page here. So it's recommended to do that in the first of this project. It's good. This all for this lesson. So don't forget to put like and share the video, and wait me to the next lesson. We will do a good project. So stay tuned and goodbye.